Year 11 mock exam question 5. So we've got a reaction from the group 7 elements, which comes from topic 1, I think. Name the products formed when chlorine solution reacts with potassium iodide. This is a straightforward displacement reaction. Again, feel free to go ahead and write this as a word equation to actually do the whole thing to give the product, or you can write both products down. Either would be acceptable. It's only asking for the products, but if you wrote down the word equation and then highlighted what the products were, you could get that. So we've got here chlorine solution in potassium iodide. I'm not going to write it as a chemical equation. You could do potassium iodide plus chlorine goes to, and then we're going to form two things. The chlorine is more reactive iodine. It's going to replace the iodine. Some people got confused here and said the chlorine is going to replace the potassium and form something called chlorine iodide, which doesn't exist. So the chlorine is replacing the other group 7 element, the iodine. So we've got potassium chloride, IDE, really important, plus iodine. It's only a 1 mark question, and you need to get both of those to ensure you get the mark. Explain why chlorine is more reactive than iodine. This is one of those questions that you just have to go away and memorize. It's a real straightforward kind of like memorize 3 steps. First thing we have to say is that chlorine's outermost shell of electrons is closer to the nucleus than for iodine. Okay, so it's closer to the nucleus. Now that means that there's going to be a greater attraction to the outer electrons. So there is a greater force. You can skip out force, but I think it's an important word. A greater force of attraction between the nucleus and the outermost shell electrons. You can't just say electrons, you have to talk about the outermost shell. Now, that means that chlorine gains electrons, or chlorine will attract electrons easier. So chlorine will gain electrons easier, or you can use the phrase less energy. Takes less energy to do it. Now, the other thing you could say, which you don't need to, but it's actually an important part, is that chlorine has less shells to shield. That's the important keyword, to shield the outermost shell. So you've got 4 points there, each possibly 1 mark, although the marking point for shielding shares the same marking point as the marking point for the greater attraction. So you wouldn't get 3 marks if you didn't mention chlorine will gain electrons easier. Question 5.3, chlorine reacts with hydrogen to form hydrogen chloride. Explain why hydrogen chloride is a gas at room temperature. So going straight to our memorization of types of bonding, hydrogen chloride should straight away flag up to us as a small molecule or a small covalent molecule. So HCl, I'm going to go straight to saying HCl. You don't have to, because you can say hydrogen chloride, but it's there. HCl is a small, covalent is optional, but I prefer to write it molecule. And then one of the characteristics of small covalent molecules is small covalent molecules. And we can actually draw it here. Here we go. There's HCl. Small covalent molecules have weak, and this is the point where we get a really important thing that people get confused at. It has weak intermolecular forces. Of attraction. A lot of people will go ahead and say that it has weak covalent bonds. This covalent bond between hydrogen and chlorine is very strong and takes a lot of energy to break, whereas the weak intermolecular forces between the hydrogen chloride molecules don't take much energy to break. And that's our last point. We can actually put that point down. Don't have to, but we can put that extra point down. These forces, and don't write bonds. We don't want to write the word bond. We want forces of attraction. These forces of attraction require only a little energy to break. Shouldn't use the word break, actually. Should use the word overcome. You might be asking, why are we not using the word bonds and why are we not using the word break? And that's because we only use the word break and bonds when we're talking about covalent bonds and when we're doing things like bond energy calculations. So it's really important to try not to use the word bond for intermolecular forces of attraction and not use the word break, but use the word overcome the forces.